These are selected scenes from the 70-minute-long MIG Welding Made Easy DVD. Check out all the Covell DVDs at covell.biz. Hi, I'm Ron Covell. I've been a metal fabricator for over 40 years, and I rely on welding for nearly all of my projects. Today we're going to explore MIG welding, which is far and away the easiest type of welding to learn and the most popular welding process worldwide. Any welding process requires focused heat, and with MIG welding the heat comes from an electric arc. The beauty of the MIG process is that filler metal is added to the weld continuously while the weld area is protected from the atmosphere by a gaseous shield. It's a fast-moving process that's easy to control and easy to use. Most people learn MIG welding more easily than any other welding process, and that's one of the key reasons it's been so readily adopted by small shops and hobbyists. So here's what we're looking for: a weld bead that's evenly rounded, that blends in nicely to the base metal, and that has good penetration. I recommend that you make quite a few practice beads just like this until you're comfortable with the process. Now let's talk about some of the variables the operator can control. The circuitry of the machine always keeps the arc length constant, but by pulling the gun farther away, the stick out gets longer. The longer the stick out, the less current is put into the base metal, and you'll tend to get a tall, ropey weld bead that doesn't blend in well with the base metal, and the weld may have poor penetration. You also lose gas coverage as the stick out increases, which could cause porosity or contamination in the weld. The travel angle is important too. 10 to 15 degrees is the angle I typically use. If the gun is held more vertically, you'll get a flatter weld bead. The more you angle the gun, the more the weld bead will increase in height, and you'll increase the stick out too. It's easy to overdo the travel angle, so whenever possible, stay with an angle no more than 15 degrees. The speed you move the gun is an important factor too. This is one of the key areas where people develop their own style. Experiment with the travel angle and travel speed to find out what gives you the best result. As you move the gun faster, the weld bead has less time to develop good fusion, and you'll get a taller weld bead that may not blend in well with the base metal. Moving too slowly begins to build up an excess of material in the weld bead and reduces your control of the puddle. Now we'll look at an application that MIG welding is very commonly used for: putting patches on automotive body panels. This fender's off a '57 Chevy, and the problem is that it has rust damage on the bottom and a poorly made previous patch. Okay, I'm ready to tack weld the patch panel into place now. So I'm going to go all around the edge of the panel, making tack welds spaced about 1 inch apart. Now we're ready to finish weld. And we have some options here. I have a couple of sample panels, and these have been welded in different ways. This panel has been welded continuously, and this panel has been welded with a series of tack welds. Let's look at the backside now. Looking at the backside, you can see I have excellent penetration on both pieces, but what I really want you to look at is the width of the discolored area. This is what we call the heat affected zone. You can see that the heat affected zone of the weld made with a lot of spots is about half as wide as the heat affected zone of the continuously welded scene. Warping is caused by the metal shrinking in the heat affected zone. The smaller the heat affected zone, the less warping we get. So I'm going to start adding on to each of the tack welds that I have. I'll make a weld about 3/16 or 1/4 inch long, adding on to each of these tacks. And after I've gone over each tack, then I'm going to stop and let the panel cool before I come back to add more weld. Okay, so we have the weld sanded completely flat, and as you can see, this really does make a beautiful repair. Some of the most challenging joints to weld are at the intersections of round tubing. A joint like this can be viewed as a fillet weld in one area, which makes a transition to a lap joint in another. Also, you want to keep the gun angle equal between the faces of the tubing as you're welding, while keeping the travel angle around 10 degrees. It takes a lot of practice to keep your motions coordinated when navigating a complex joint like this, but the more you do it, the easier it gets. Let's get set up to do some welding on aluminum. I'll be maintaining the 45-degree work angle and the 10 to 15 degree travel angle as I make this weld. Okay, so there's our finished weld. I'll spin this around so you can take a close look. Notice how clean and free of defects the bead is. This is a real boon for people who do a lot of welding of aluminum plate, such as building boat hulls, tanker trailers, and many other types of industrial fabrication. There's a little bit of soot on the weld, but that cleans right off with the wire brush. I'm confident that you'll have fun as you explore the world of MIG welding, and I hope you're eager to get started. So until next time, this is Ron Covell signing off. Learn metalworking and welding from a master. Covell DVDs, the standard of the industry.